This is the molecule to molecule notes video for stoichiometry. If you have been, if you've watched the previous two videos, you're probably getting the hang of it. The mole to mole conversion is a part of any stoichiometry that we do as we go from substance A to substance B. So changing substances based on the ratio of our balanced chemical equation. Now with this, we do have just that molecule conversion, so molecules to moles. Then that's going to be our first step. Our second step is going to be that mole to mole conversion, switching over substances, and then finishing off with another conversion with molecules, but now going from moles of our B substance, our unknown, to molecules of that substance. All right, so if we look at this anytime, as we're looking at these stoichiometry problems, how many molecules of oxygen are needed to completely react with 5.24 times 10 to the 23rd molecules of sulfur dioxide? I have molecules of both. I'm switching from sulfur dioxide as my chemical to oxygen. And so this is going to be 3 steps going kind of through that path that was initially discussed. So this is 3 steps. As we're going about doing this, notice we have our balanced chemical equation. And so we're going to start with our given value, 5.24 times 10 to the 23rd molecules of SO2. We want to make sure we're labeling units, which are molecules, and the substance so that we can stay organized with what substance we're at. Next, we are getting rid of molecules of SO2. And so I'm going to put my 6.022 times 10 to the 23rd in the denominator. And I know that definition of a mole, 1 mole is that many molecules. Now that I'm at 1 mole of SO2, that's my substance A. Now I can use that balanced chemical equation, which is kind of that formula, the ratio of everything we need in order to switch to that oxygen. And so I'm going to put moles of SO2 on the denominator, since that is what I need to get rid of. And then the substance that I'm changing to, what I want oxygen. I'm looking for molecules of oxygen. I'm going to do moles of oxygen in the numerator. And that is O2 because oxygen is diatomic. And then where do we get the values that go into this reaction? Well, my reaction is showing that I have 7 moles of oxygen when I have 4 moles of SO2. So that's going to be 7 moles of oxygen over 4 moles of SO2. Now that I've switched to that oxygen, now I can go moles of oxygen to molecules, which is where the problem asked me to go. And so then I'm going to have to show my work down here. Moles are on the numerator here, so moles are going to go in the denominator. Moles of oxygen. I want molecules of oxygen in the numerator. And back to that definition of a mole, 1 mole is 6.022 times 10 to the 23rd molecules, so that's going to go on the top. And this is a little tricky to see since I couldn't put all of these in a straight line. But as we go through and we look, again, we can check our units. Molecules of SO2, those cancel. Moles of SO2, those cancel. I have 1 in the numerator, 1 in the denominator. Moles of O2, those cancel. And the nice thing when we're looking at our molecule to molecule conversion, because that definition of a molecule or of a mole is the same for those molecules, that value isn't changing. We have a 6.022 times 10 to the 23rd in the numerator, in the top of one of my conversion factors. I also have it in the bottom, and so those actually cancel as well. You're welcome to do your calculations with those in there, but we can also cancel those to get that, to kind of simplify our math, and it also kind of helps us prevent any math errors. All right, so now when I look at this, I'm going to go and do my calculations. I'm going to multiply 5.24 times 10 to the 23rd. times 1 times 7 times this 6.022 times 10 to the 23rd canceled, so I'm not going to include that in my numerator calculation. 3.668 times 10 to the 24th, and then I'm going to need to divide it by whatever's in the denominator. 1 times this canceled, so I don't need to do that. 4 times 1, which is going to just be 4. So then I'm doing 3.668 times 10 to the 24th divided by 4, and I get a value of 9.17 times 10 to the 23rd. That's exactly what my calculator told me. My sig figs match up. I need 3 sig figs from my 5.24. My Avogadro's number has 4 sig figs, and both of those there. Our molar conversion ratios, these are exact numbers, so those don't count to sig figs. So my final answer is going to be 9.17 times 10 to the 23rd, and I need to go and add on the units and substance, molecules of oxygen. All right. One more, again, this one's going to be 3 steps, that molecule to molecule. And we see that cancellation with that Avogadro's number, but we still need to make sure we're setting these up correctly when we show our work. So how many molecules of, so we're looking for molecules of iron oxide, which is Fe2O3, are produced from, molecules, so we need to know molecules and the substance, are produced from 3.3 times 10 to the 22nd molecules of iron sulfide. So this is our starting value. So I will have my 3.3 times 10 to the 22 molecules of iron sulfide. That's my FeS. I need to get rid of molecules of iron sulfide and go to moles of iron sulfide, because getting to moles of iron sulfide is how I can do that molar conversion, that molar ratio using my reaction. So that's 6.022 times 10 to the 23rd molecules underneath 1 mole. And now I'm getting rid of my moles of iron sulfide. In my reaction, I have 4 moles of iron sulfide, and I want iron oxide. And my reaction, I have 2 moles of iron oxide. That last step then is get rid of moles of iron oxide. And I need to get to those molecules. So 1 mole is 6.022 times 10 to the 23rd molecules of Fe2SO3. This is messy. It doesn't let me actually zoom in on this program. So Fe2O3, as what my chemical was there. So, again, looking at our units, molecules of FeS, molecules of FeS, those cancel. Moles of FeS, moles of FeS, cancel. Moles of Fe2O3, moles of Fe2O3, those cancel. So we're going to be left with our molecules of iron oxide, which is what we want. When we go to do our math, we can multiply across the numerator. 3.3 times 10 to the 22nd times 1 times 2. And let's calculate this one including that Avogadro's number in there, so we're not actually canceling it out, just to make sure we get the same thing. So I end up with 3.97452 times 10 to the 46 in my numerator, dividing by, and we're going to multiply everything in our denominator. 1 times 6.022 times 10 to the 23rd times 4 times 1, which is 2.4088 times 10 to the 24th And I can divide those out in order to figure out that final answer. And I got 1.65 times 10 to the 22nd when I did that division. If we had canceled out that 6.022, our values here would be different, but we should still end up with that same final answer. Making sure we have correct sig figs. 3.3 has 2 sig figs. The Avogadro's number has 4. Our molar conversion coefficients don't have sig figs. Those are exact values. So we are going to want 2 sig figs in our answer. 1.7 times 10 to the 22nd. And then molecules of Fe2O3. All right. Next on the list is the mixed Stoich. So kind of starting and ending anywhere. Reach out to your teacher with any questions.